So in this little video, I'm going to run down about how to approach generic Newton's first law problems. And after some feedback, I realized that there's a bit of confusion of how you exactly approach these problems and what the physics really means. So I'm going to start with the case that we have a free body diagram already drawn out. So I think that everyone so far has been able to understand how you draw a free body diagram. If you're confused about that, you should definitely send me an email as quickly as possible, because this should be old news by now. So Newton's first law tells us that if we see that an object is not accelerating, so this means moving at a constant speed, or not changing directions, then what that means is in the direction in which these two things hold, so perhaps this is something moving in a constant speed, or perhaps it's in free fall in one direction but it's at a constant speed in another direction. In every single case in which you have Newton's first law holding of something moving at a constant rate where there's no acceleration, if you see no acceleration in a direction, by direction I mean x or y, and you can say in each direction that the sum of the forces in that direction, which I'm going to call direction I, this could be x or y, then those have to sum up to be equal to 0. So in practice this means in the x direction you can say that the sum of the forces are equal to the x direction of the first force. So this is this x component of this force. Forces are vector quantities, so they have components that you can draw. They have an x component, so the force in the x direction, there's a force in the y direction that they sum up to give you this total force, this resultant force. So you can break them up into their components, and the x direction of the force of the first force would have to add up with the f direction, or the x direction of the second force, plus the x direction of the third force, would have to equal 0 if you saw no acceleration in the y direction. The same is true for the x direction. The same is true for the y direction. So in the y, in up and down, then you can say that the sum of the forces in the y direction equal to the first force has a y component. You add that to the y component of the second force plus the y component of the third force, and you set that equal to 0. And oftentimes what we're worried about is we're trying to say, okay, let's say I have these three forces. I know what one or two of them are, but I want to find what the other one is. Particularly in one of the problems in your homework, I give you three forces and I tell you, well, there's some force here, force 4, in some direction, which we draw our angles from the positive x-axis counterclockwise. So this is theta 4. I give you some fourth force that actually you have to include in your calculation to try and find out. So I give you F1, F2, and F3, and I give you their directions. So with the angle and with the magnitude of the force, which means the strength of the force, how big that force is, with those two numbers you can find all the components. So I would actually get rid of these little equal to 0 parts and have to add on an extra force. So I would say plus the x component of the fourth force, and then set that equal to 0, because I told you that Justin Bieber is being torn to shreds, thank goodness, and he needs to, there has to be some fourth force to take into account to prevent him from moving. So he's being pulled in multiple directions. I give you three of the forces, and I tell you there's some fourth fan that is pulling on him in both the x and y direction. I want you to find what these components are, and then use these components to find the total force that this fan is pulling on him, and then also the direction of that force. So this is just like the vector homework that we did, that I think I've turned back to everyone, so you should review that homework if you're confused of how to use components to find the force. So just really quickly to explain how we find the components of this force. So we know that, let's say I redraw this little free body diagram. I have a force like this for F1. I'll just do F1's case. I'll have you guys do the rest. Here's our angle 1. I know that this force has an x direction, which I'll mark in red. This is F1x, and it also has a y direction, a y component of the force, which add up to give you the total F1. And I did this such that I flipped this 1 and y. It doesn't really matter. I'm just not being consistent. So what I would do with this, I would use my trigonometric function. So remember SOHCAHTOA. And if I want to find the y component of that force, then I need to use my sine, because opposite over hypotenuse, this is the opposite, and the hypotenuse is the magnitude, or this F1. So F1 is this magnitude. So I would say the sine of theta 1 is equal to my y component of force 1 divided by the magnitude of that force. And then I can rearrange this to solve for the y component. So I give you these two, I give you this, and I give you theta, and you can solve for f1 of x. And I can do the same thing for the other direction, or for the x component. I know that cosine is the adjacent over the hypotenuse, and so the cosine of the angle is equal to f1 of x over f1, and that is going to give me so I know this, I give you this, and I give you this angle. We measure those in some way, and I give them to you, and you have to compute what the x component is. And so you can take this x component and you plug it into our equation up here, and then you can do that for the other two as well, and then you can solve for this guy. Then you can do the same thing for the y component. You can bring the y component up here, plug that in here, and then do the same thing for force 2 and force 3, solve for the y component of force 4, and you will find that, okay, now that I know the x component and the y component of my force, so you know the x component, which is f4x, and f4y, 4y, you know those two things, and so you can use the Pythagorean theorem to find what f4 is, what the total magnitude of this is, and you can also find the angle using the tangent function. Though you should define this angle like this if you want to get it correct. And tangent of theta 4 is going to be equal to f4y over f4x, and then you take the inverse tangent function of both sides, and you're done. So if you have any questions on this is the standard free body diagram approach for Newton's first law, and we'll be using the same thing in future sections, but instead of equals to 0, we'll have something else over here. So we're going to be using the same approach multiple times over the next couple of weeks, so you need to get used to realizing, okay, I have a Newton's law problem. I need to break my forces down into their x and y components, and then sum them up and find out what they add up to, because we're going to be using this what they add up to tell us something about how objects accelerate and things like that in our upcoming chapters. So I hope that helps. If you have any further questions, you need to email me or Skype me or do something to get some help. Otherwise, I kind of expect you guys to be able to do this by using my example and using our notes in class and the examples we do in class. So if you have any questions, email me. Good luck.